Let me say a few words about the NTSB to begin with. We're a relatively small organization by government standards. We have about 400 people. Most of that is staff. We have 5 board members. And the 5 board members are appointed by the President, confirmed by the Senate. We're on rotating terms, 5-year terms. So that lessens some of the political pressure. We're an independent agency reporting to Congress. So we don't report to the Department of Transportation. We have an independent ability to look at aviation safety as well as other modes of transportation. So we're really not the National Aviation Safety Board, we're the National Transportation Safety Board, and we do rail, pipeline, marine, highway, and so forth. So that's my sponsor. A word for my sponsor. We'll try this. Okay. In the past, we've had a process, what we call the Most Wanted list. And the Most Wanted list was recently revamped. It started about 20 years ago. And that Most Wanted list started by recommendations that were important recommendations that we held on the Most Wanted list until they got satisfied. Well, unfortunately, that turned out to have about 59 or 57 most wanted items. That's the priority items. And of course, if you've got that many priority items, you don't have priority items. So we've boiled the list down to 10. And I fought hard to get general aviation on the most wanted list for a number of reasons. It's one of 10 issue areas. So we've now got the focus down to 10 areas. We're going to review these areas annually so that we will have a rotating most wanted list. And it allows us to bring focus on the need for improvements. So that's what I'm doing now. I'm hoping to bring focus on the need for improving general aviation safety. Why is it on the most wanted list? Well, one of the things I realized when I took this appointment was that we have the biggest chunk of our organization is the Aviation Safety Division. Out of the Aviation Safety Division, we have a major accidents organization and we have a regional accidents organization. For those of you who've been watching transportation or specifically airline safety, you realize on the airline safety side, there's not a lot going on, which is fortunate. But when I say not a lot going on, it's been 10 years since the A300 accident in New York City, which was the last really large loss of life. We've gone more than 3 years since the Buffalo accident, the Colgan accident, and that had 51 fatalities. The only other major accident we've had where we've lost an airplane was the 1404 Continental runway excursion in Denver about 4 years ago, and no loss of life on that. So there's not a lot going on the 121 side, fortunately. But on the Part 91 side, we investigate about 1,500 accidents a year. And that's a lot. So I want to bring some focus on that 1,500. The other point to bring across here is the overall GA accident rate is flat. Now, that may sound okay, but I'll show you in a moment the accident rate for what we tend to do, the personal flying, is not flat, it's not going down, it's going the other way. So that hasn't improved over the last 10 years. Well, in the meantime, the air carrier accident rate has declined 80%. And that's largely due to government and industry working together closely through things such as the Commercial Aviation Safety Team, CAST. So 15 years ago when I was on the air carrier side or the large transport side, when we talked about an 80% safety or accident rate reduction, we kind of looked at each other and said, how the heck are we ever going to do that? But it has happened. So about 12 years into the program, it was down 80%. Whereas the personal accident rate has gone up 20% over the last 10 years. By personal accident rate, I mean that flying which is not corporate, it's not business, it's not instructional, it's the rest of it. The fatal accident rate has gotten even worse. That's gone up 25% in the last 10 years. Now, for those of you who are graphically oriented, we'll look at some charts in just a moment. But that brings me to the line that GA personal flying, again, the flying that most of us do, the flying I did to come down here, needs attention. If we look at all GA accidents over the last 10 years, now this is all GA, so this is including corporate, business, instructional, and so forth, it looks like we're coming down. But in fact, the number of flight hours have come down faster, so that the accident rate, I'll show you in a moment, has not gone down like you see here. But notice, even in 2009, the last year which we've got complete data for, we've got about 1,500 accidents. 1 out of 5, 1 out of 6 is a fatal accident. If we look at the fatalities involved, that's gone down a bit. But again, if we divide out by the number of flying hours, it didn't really go down. But let's put it in perspective. We lose almost 500 people in the United States in general aviation accidents. A typical fatal accident has almost 2 fatalities. If we look at the rates per 100,000 flight hours, the top line is the total accident rate, and as you see, we started in 2000, where we ended in 2009 is slightly higher. If we look at the bottom line, which is the fatal accident rates, that line is remarkably flat. For those of you who know something about statistical process control, that process is under control. It's a stable process. What we need is a little instability in the accident rate, something that bumps it off of where it is and makes it go down. What are the accidents that really define fatal accident rates? Well, the top item is loss of control in flight, followed by loss of control on the ground. Abnormal runway contact, and again, I'm talking about all accident rates. Power plant failure. Controlled flight into terrain, that's an old one that's been around for a long time. Unintended flight into IMC, that's not a new one. System or component failure, non-power plant, fuel management, and collision on takeoff or landing. And I really don't have the top 10, I have the top 9. So if we look at corporate, to put it in perspective, the accident rate for corporate approaches that of the airlines. Some years there have been no fatalities in corporate flying. By corporate flying, I mean a professional flight crew. Business flying is generally owner-flown aircraft being used for business purposes. That's shown a modest decline, and it's substantially below the overall GA accident rate. Instructional flying, well, accident rate slightly below the average for all of GA, but the fatal rate is substantially lower. So there's a lot of fender benders in this category. Then we come to personal. Total and fatal accident rate both are on the rise, and both are substantially above the average for all of GA flying. Well, what does that look like? For GA overall, it hovers between a little over 6 to roughly 7 for that 10-year period. Corporate is right down at the bottom. So when I said their accident rate's almost that of the airlines, that's where it is. Business flying actually has gone down a little bit. It hovers around 2 to 1.5 or less fatal or overall accidents per 100,000 flight hours. Instruction, just a bit below the average, and there is the personal flying accident rate in red. Hardly going down, is it? It's gone up from 10 to 12 at the end of that 10-year period. If I look at just fatal accident rates, a little over 1 fatal accident rate, a fatal accident per 100,000 hours. Corporate is down at the bottom. Business. Instructional, it's interesting. It's about the same fatal accident rate as the business flying. And when you think about it, it's not a surprise, since many of these airplanes are being operated with commercial pilot on one seat doing the instructing. But unfortunately, the general aviation personal flying has gone up from around 2 to around 2.5 fatal accidents per 100,000 flight hours. So let's characterize these a little bit. Business flying, for the all accidents, the loss of control in flight or on the ground is the most prevalent event, followed by system or component failures. If we look at just fatal accidents, loss of control in flight accounted for the greatest proportion, and then we have CFIT and collisions. So if we look at it in a bar chart format, not a lot of accidents actually. 12 accidents in the loss of control in flight, 5 CFIT, 4 collisions, 2 power plant failures, and 1 fuel management. Fuel management shouldn't be up there. If we look at instructional flying, it's loss of control in flight or on the ground, abnormal runway contact, not a surprise since a lot of flying and instruction is teaching people how to land the airplane. 122 loss of control on the ground. 118, almost the same number of abnormal runway contacts, and 88 loss of control in flight. Now let me move to personal flying accidents. You can see that it has gone down, but it's gone down not as fast as the number of flight hours has gone down. So look at 2009. We had over 1,000 personal flying accidents. And personal flying, remember, is 1/3 of the flight hours for general aviation. So those accident rates are going up in both overall and in terms of fatals. So if we look at the bar chart, loss of control in flight, 250 in a 3-year period. That's over 80 every year. And that's fatal accidents. I get a page every time we have a fatal accident, a page on my BlackBerry. And some days I've seen 4 fatal accidents in one day. Loss of control in flight, controlled flight into terrain, power plant failure. In fact, we'll go down this list and I'll address all 5, I'll address 5 out of the 6 categories. There's a fellow by the name of Alfred Scheinwald who is a bridge player, but he had a quote that I thought was really appropriate for this audience. Learn all you can from the mistakes of others. You won't have time to make them all yourself. So let me look at the mistakes of others here. And let me use the paradigm of the accident as being the end of a chain of events. Not necessarily a new paradigm, but one that I think you'll find quite useful. So think of the accident as being the end of the chain of events, and if you can break that chain in any point, you eliminate the accident. So as I go through these, keep in mind this model and look for opportunities where that chain can be broken. So let me start off with number 1, loss of control in flight. What kind of airplane is this? Pretty hard to tell. It apparently had a lot of fuel on board because of the fire. It is a pretty small impact area, so it was probably coming down pretty near vertical. That, by the way, is a Beach Bonanza, A36. I'm giving you the accident numbers because at the end I'm going to encourage you to use the NTSB website as a means, particularly if you're an instructor or interested really in safety. You can go on the NTSB website, look these accidents up, and get more than a summary. You can get, in many cases, into the docket where you can get factual reports, interviews, photographs. For a flight instructor, it makes a good teaching tool. As I said, it was an A-36. It was on approach to Carlsbad Airport, and the airport elevation is 331 feet. That's a number, just keep that in the back of your mind for a moment. One person on board, thank goodness, only one person. What do you think of that weather? 100-foot ceiling, quarter mile visibility, light winds. You know, typical marine layer for being close to the ocean in Southern California. Unfortunately, he was on an approach that had a 203-quarter mile minimums. Of course, for a general aviation aircraft, we can't handle 100-foot ceiling, quarter-mile visibility anyhow. That's really in the Cat 2, Cat 3 area. Well, why would somebody launch off into conditions? By the way, that was forecast to be that low. The pilot had a private certificate, had an instrument rating, but not very old instrument rating. 2 months since he got his instrument rating. And by the way, he didn't have any training in that accident aircraft. So he launched into a hard IFR situation with no actual instrument training in the airplane. And one can kind of guess as to how much instrument time one's likely to get in 2 months if you're in the southern US area. Not a lot of instrument time available in New Mexico, Arizona, and that area. The airplane had no apparent malfunctions. It had adequate fuel, as you can tell by the fire burn. So what was going on? Well, ATC cleared the aircraft for an ILS approach on runway 24. So he's landing to the west, southwest. And during the approach, the tower called a low altitude alert as the pilot was going through the localizer. So he was headed to the south. The localizer was a west-southwest heading. And 2 minutes later, the pilot said he was aborting the approach. Aborting in quotes. He didn't call a missed, so probably the guy was under some stress. And in fact, a minute later, he said he was in trouble. That's the last that we heard from him. If you look at the radar tracks, you see that 2 miles from the approach end, he did cross the localizer at 800 foot headed south. So he's about 60-degree cut to the localizer. So this is not a cut to get back on the localizer. I should have put the radar tracks in here because they're really informative to look at, but let me just describe them. He started wandering around, but then started making tight left-hand turns, and literally tight turns. His altitude during those turns went from 600 feet to 1,100 feet. So in other words, he's about 300 feet or less, up to about 800 feet. The last radar return showed him at 900 feet, but 56 knots of ground speed. 56 knots of ground speed, going up and down like that, you can kind of guess this is a stall spin accident. So what kind of opportunities were there to break the chain? You know, starting out with launching into hard IFR that's below minimums, launching without good experience, launching in an airplane that you don't have any IFR experience in, and the list goes on. The wreckage was confined to the very small area, and the probable cause was pilot's failure to maintain control during the instrument approach and attempted go-around. But the real interesting story is the story that you get by looking at the facts, the factual reports, and the radar data. But lots of opportunity to break that accident chain. Nothing wrong with the airplane. So let me move to category number 2 as I move down the list of the top 5. So what kind of airplane do you see here? The hint is over on the left-hand side. You can see a little bit of fiberglass. This was the CFIT. The accident was investigated out of the New York City office. It occurred in 2008. F is for fatal, and it was 138th in the accidents investigated out of that office. It was a Cirrus SR-22. It was a night departure out of Front Royal, Virginia, and we don't know what the weather, well, let me just point out, you know, as a lot of these, this was a pilot and his son. The pilot had flown out of Baltimore to Front Royal to pick up his son. This was late at night. This departure was about midnight. It was just a short flight intended to go back to Baltimore. And the weather at Winchester, which is 15 miles south, is all we know because Front Royal doesn't have weather reporting. But 15 miles south, they had light winds out of the northwest, 4 knots, 3 miles visibility, 2,400 foot overcast, or broken at 24, overcast at 3,000. So for an IFR operation, not particularly bad. The pilot had a private pilot certificate and an instrument rating, 193 hours, so not highly seasoned. The airplane was a relatively new airplane, less than 300 hours. The airplane had no apparent malfunctions. As is the case with some of the more modern aircraft, modern flight data systems, or the primary flight displays, they'd log some data that in many cases we can pull off and understand at least some of the things that were going on. It's not like having a flight data recorder on a 121 operation, but at least it gives us some insight in many cases as to what was happening during the accident sequence. He got a clearance for departure, direct Kogan intersection, climb and maintain 4,000, expect 5,000 10 minutes after departure. Pretty standard clearance. It's a relatively short flight, so 5,000 is probably good altitude, and he's headed back eastbound again. Now, prior to takeoff, he set his desired course to 50 degrees, which is to the northeast, which is the direction of the Kogan intersection. So that part, so far, so good. But when he departed on runway 27, now, what's the topology? For those of you who know where Front Royal is, what's to the west? He's taken off to the west. What's to the west? Lots of mountains, yeah. During the takeoff roll, he selected the Kogan intersection on the GPS. Kind of interesting, he's doing this during the takeoff roll. The airplane path continued to the west, but it continued to the west consistent with not having made the mode selection to engage the autopilot. And in fact, the flight path was only 80 seconds long. During the first 40 seconds, it looked like pretty well under control. He was climbing steadily, about 1,000 foot per minute. He was on the runway heading. And then things started to go bad. The next 25 seconds, the vertical speed went to 0, so he leveled off. Then he had a high rate of climb. Then the climb decreased to nominal climb rate. Airplane reached 2,200 foot at 140 knots. And during the last 6 seconds, he made a steep descending turn to the left, more than 90 degrees roll angle, and pitched down to 27 degrees. Really lost control of the airplane. So you can kind of imagine perhaps what was going on. I think he was probably working on the autopilot, trying to figure out how come the autopilot didn't engage. But again, that's my speculation. That's not NTSB speculation. It's just the sort of thing that instructors like to do to play in their minds. What could have been going on during that sequence? The probable cause just says, well, he failed to maintain clearance from the rising mountain terrain, failed to turn toward his assigned course. Contributing to the accident were low ceilings, reduced visibility, dark night conditions, and rising mountainous terrain. But here's a guy with a fast airplane. His 190 3 hours of flight time. Probably didn't have a lot of fast airplane time. He may have been used to something going much slower. Sounds like he got behind the airplane. Again, that's my speculation. But what were the opportunities to break that accident chain? I think there were several in there. You know, we have duty time restrictions for Part 121, 135 operators. We don't have any duty time restrictions for Part 191 operators because we are our own dispatch. We are our own operator. But how many of you actually think about fatigue? Here's a case where it's a night departure. It's about midnight. We've got a pilot who's probably fatigued, making a bunch of operational errors. Again, speculation. Pressure to get his son home, yes. And pressure to show that he can use the airplane productively for something like that. At the last, very last, again, I'm speculating, he may have seen something which caused him to react, because it was a very violent reaction right at the last. Let me look at something here which sounds like this one's not a pilot problem, because the other two were pilot problems. This is a power plant failure. The landing gears used to be on the other side of the airplane. So this airplane's upside down. Notice the cockpit area, the survival space is pretty small. It was too small. This was a fatal accident. One person. This accident was investigated out of the Eastern Region, the Ashburn, Virginia office, and it occurred in 2009. It's a fatal. I'm not really picking on Beechcraft, but I originally put this presentation together for the Bonanza, American Bonanza Society. So I was picking on Beechcraft, but there are plenty of, if I want to be an equal opportunity, there are plenty of others to choose from. This occurred on a night IFR approach into Louisville, Kentucky, Louisville. It was a flight out of Midway. One person on board, one fatality. The weather wasn't too bad, 330 degrees, light winds, ceiling 800 foot, good, reasonable visibility, not a hard IFR sort of approach condition. And the pilot had a fair amount of experience. He had a commercial, single engine, multi-engine. He was a flight instructor, he had an instrument rating, had 23 hours total flight time, so relatively seasoned. The airplane was a fairly high time airplane, 6,200, almost 6,300 hours. But the engine had been overhauled 58 hours prior to the accident. He bought the airplane with 18 hours on a fresh overhaul. So he'd flown the airplane about 40 hours. He'd had a problem with the oil pressure. He'd been advised by some mechanics to have it checked. He hadn't gotten around to it. The accident sequence was this. He'd flown into Midway. It's now midnight, and he's got a problem with the airplane. It doesn't want to start. So they roll it in a hangar, only to find out that the mechanic's not going to be available till 8 o'clock in the morning. So being impatient, he decided to pull the airplane out of the hangar, did manage to get it started, and departed for Louisville at a little after 2 o'clock in the morning. Probably not all that fresh at that point in the circadian sleep cycle. 9 miles out on an RNAV approach in Louisville, he declared an emergency because the engine failed. The airplane struck a tree on a golf course, came to rest inverted about 175 feet away from the tree, with the front of the cabin very much crushed in. There was fuel on board the airplane. So it wasn't a matter of fuel exhaustion. The initial examination, however, found that the engine would not rotate. So there was a teardown. And during the teardown, they found that the crankshaft and the counterweight assembly fractured on the number 2 main bearing journal. The journal showed scoring consistent with bearing rotation, so the bearing is spinning now. And that the number 3 bearing journal fractured at the rear fillet area. So they sent that bushel of parts, several bushels of parts, to the materials lab back in Washington, D.C. The lab investigation found silk thread patterns in gasket-making material on the sealing surfaces on the main bearings bosses, not something that was part of the maintenance documentation from the Teledyne Continental service bulletins. So the assessment was the main bearing boss was severely damaged on both halves, including rotational mechanical gouging, basically because the right gasket material wasn't used. So here we have a fellow departing on a night IFR with an airplane with a known deficiency. Where were the opportunities to break that chain? Several. It's hard to put yourself back in the mind of the pilot, but yes, why did he depart with an airplane which wasn't in good shape? So the probable cause, pilot's continued operation of an aircraft with known deficiencies. Contributing to the accident was the improper sealing of the engine case during overhaul. So let me move on to the next swinger here, unintended flight into IMC. And again, let's play the guess the airplane. It apparently had fuel on board because there's evidence of fire. That's a Cessna 182. The accident was investigated out of Denver. That was the scenic Rocky Mountains that you saw in the distance there. There were 4 fatalities, pilot and 3 passengers. What it doesn't say is there was a family. They had come from a vacation. They'd been at Steamboat Springs and were flying back to Texas at the end of their vacation. No record of weather briefing. No flight plan filed. Of course, none of us do that. It impacted terrain in Park County, Colorado at about the 12,000 foot level. The weather in the area was IMC, not VFR. He launched into VFR, he thought. Pilot had a private single engine land, multi-engine land, instrument rating, 1,500, almost 1,600 hours, so relatively seasoned again. 154 actual, 40 simulated, so he had a fair amount of time on the gauges, assuming that that's accurate. The airplane had plenty of information on board. It was a relatively new airplane, a Garmin 1000. He had XM weather. He had a storm scope. Storm scope's particularly interesting because, as you'll see in a moment, the airplane had about 1,500 hours total time on it, and no evidence of anything wrong with the airplane. Because we don't have weather information, we've got some really crack folks at the NTSB who can go back and get a pretty good idea of what the weather was at the time of the accident. So they figured he departed into marginal VMC, had an overcast above and scattered clouds at and below his flight level. Weather at the time of the accident was deteriorating rapidly, and he likely encountered a level 2 thunderstorm. Now, he had a storm scope, he had NEXRAD weather, but it didn't keep him out of trouble. He impacted the terrain at approximately 55 degrees nose down, wings level, at 12,300 feet. Probable cause, again, sounds a little sterile. Failure to maintain control and after inadvertently encountering instrument meteorological conditions. But contributing to the accident were the pilot's failure to obtain a weather briefing and the severe weather conditions. And maybe some overconfidence because he had XM weather, he had a storm scope, he had an instrument rating. Why didn't he use it? Fuel management. As I said earlier, this one should have gone away a long time ago. But pilots are inventive in terms of coming up with ways to mismanage fuel. That big white thing that you see there is a rolled bale of hay. This is an A36. Accident occurred in the Alabama area. An A36, 2 fatalities, 4 people on board. The 2 forward passengers were fatally injured. The 2 aft passengers received only minor injuries. They were on an IFR flight plan, but flying in VMC conditions. They were coming from Destin, Florida to Newman, Georgia. The accident occurred in Alabama. Weather at the time was not an issue. Scattered 3,900 foot, 10-mile visibility, winds, light winds. Pilot had a private certificate, instrument rating, 1,600 hours, and a reasonable amount of instrument time. But the instrument issue was not relevant here, really. The airplane had a recently turbo-normalized engine, and it, as I recall, it was a borrowed airplane. They put tip tanks on it because the A36 only carries about 74, 76 gallons of fuel. So a lot of people add tip tanks to get another 10 gallons per side or another 20 gallons. Relatively new airplane, and again, no evidence of pre-impact anomalies to the airplane. The accident sequence, well, they made a short hop to pick up 3 people. He was in cruise at 7,000 feet when the engine lost power. He temporarily got it restarted, but then lost power again. So he identified a pasture, looked like a good choice for a forced landing. Unfortunately, he hit trees and that large rolled bale of hay. He did have enough presence of mind to have the 2 aft passengers get in the aft-facing seats, which probably accounted for them having only minor injuries. But what was interesting to look at the accident scene, the fuel selector was on the right tank. The right tank was not breached and had about a quart of fuel present. The right tip tank was breached but had 4.5 gallons out of 10 gallons. The left fuel tank separated from the airplane, but there was no evidence on the vegetation underneath that there had been spilled fuel. So the left fuel tank was probably empty as well. The left tip tank was breached but had a half gallon left in it. Now, before the trip, he had done a weight and balance calculation. He'd loaded the airplane to 74 gallons with 20 gallons in the tips, but then realized that he was overweight. So they found 25 gallons of fuel in containers in a hangar. So that he had offloaded 25 gallons of fuel. Offloaded presumably out of the mains. So the mains then were down to a little less than 50 gallons. Now, we don't have good flight data, but we did make a calculation that he probably, by that point in the flight, would have burned about 48.6 gallons, which is what he had in the mains. So we presume that he used the mains up, but not the tip fuel. So you can see there were, again, plenty of opportunities for this accident sequence to be cut short. The probable cause was improper fuel management. It's interesting that something like 5% of the fatals are related to fuel exhaustion or fuel mismanagement. But in many cases, the airplane crashes only to find that there's fuel in other tanks than the one that was being used. So if we look back at the accidents from an accident chain point of view and try to categorize them, several accidents had pilot proficiency issues. We had a launch into hard IMC with a new instrument rating and no instrument experience in that airplane. We had system operational confusion, use of the autopilot on a night IFR departure into rising terrain. This airplane had recently had a turbo normalized engine. I don't recall reading that the pilot had had any considerable experience in the airplane. So he mismanaged fuel, not proficient in it. We had an airworthiness issue with a night takeoff into IFR with a known deficiency. Then there's a whole area of preparations and planning. Launch into weather with destination forecasts to be below minimums. Launch of VFR into instrument meteorological conditions with no IFR flight plan or recorded weather briefing. You know, this turns out to show up more often. Pilots with instrument ratings caught scud running or deciding to fly into IMC and with the result of having an accident. Lots of poor decision making. Numerous points where if the decision had been made a little differently, the outcome would have been entirely different. So lots of opportunities to break that accident chain. I encourage people, as I said earlier, to try this at home. You can download off the NTSB website documents like this, which is the 2007-2009 aircraft accident data. The 2010 data, as I recall, has just been made available on the web. And the accident files are available online, as are many of the dockets. And in those are factual reports, interviews, and photographs. All you have to do is go to ntsb.gov. That may be oversimplifying it a little bit. We recently improved the website, and like all improvements, there's some bugs in the improvements, but nevertheless, with a little perseverance, you can find out an awful lot of good information. So, a fellow by the name of Doug Adams, he wrote The Hitchhiker's Guide to the Galaxy, I thought made a very apt comment. Human beings who are almost unique in having the ability to learn from the experience of others are also remarkable for their apparent disinclination to do so. So there's lots of places that we can learn stuff if we only are sensitive and receptive to learning. So the equipment we fly is much more capable of safety than many pilots achieve. You know, we talked about corporate pilots, professional pilots having that accident rate way down at the bottom. But all the accidents I've shown you have been due to decisions that the pilots made, decisions that he has or she have made that has led to the accidents. So there's a lot of safety built into the airplanes that all we need to do to take advantage of is to change the way we operate. So the question is, what accident rate do you want to operate on? Do you operate on the same accident rate when you're flying by yourself as when you have family and friends aboard? Think about that. Where do you want to operate? Down with the corporate? Or the business? Or the instructional? Or the personal? That's really up to you. I thank you for your attention.